Hello, I'm John Fitch. Man, since the beginning of time, has wondered about the stars and the planets. Our neighbor planet Mars has intrigued the imagination of artists and writers. Some people think there is life on Mars.
I see a vast network of channels crisscrossing the planet. Obviously the work of intelligent Martians. The simplicity and symmetry cannot...
It will be possible with larger telescopes to see cities on Mars, to detect navies in its harbors.
The inhabitants of Mars are vast, cool, and unsympathetic intellects, looking across space at the planet Earth with envious eyes. Are they planning an invasion?
We've been looking at Mars the way artists and writers imagine it. A planet of jungles and deserts, inhabited by monsters, and of course, beautiful women. Well, I'm happy to say that they are wrong. Mars is far more mysterious than that, and far more surprising.
Of all the planets in our solar system, Mars has always held the most fascination. There is no longer hope of little green men. But the question of whether microbial Martian life might have once, or still might exist, remains. This is the story of the first pioneering missions to reach Mars, and how each encounter resulted in surprise, dismay, or delight for those who first took us there.
Each time we got more data, each time we got closer, that image was completely obsolete. That's still going on. That's the amazing thing.
The changing face of Mars. Beginnings of the space age. Next. In the Cold War between the United States and the Soviet Union, the space race was a great drama played out before the entire world. At the beginning, the Soviets, with their powerful rockets, were far ahead. But that began to change when NASA's Jet Propulsion Laboratory scored America's first in space by sending a robotic spacecraft sailing by Venus in 1962.
And in those days, intense Cold War rivalry, you were dealing with things that had military implications. And so countries of the world were trying to say, well, who's going to win this? Who's going to be the dominant military power? And so we had a lot at stake. It wasn't just trying to get a satellite.
The name of the game was Beat the Russians. The space race was very real and very tangible here at JPL. We knew that our job was to get there first and get there best.
And now JPL was aiming for Mars, as were the Soviets. In June of 1963, Mariner project manager Jack James announced results of the latest Russian attempt to reach the Red Planet.
Today, the USSR spacecraft Mars 1 made its encounter with Mars, dead as a doornail. The Soviets have made at least 7 launches to Venus and Mars, none of which have succeeded. You are better than they are. You are one of the individuals who can make Mariner the first spacecraft to make measurements of the planet Mars. This depends on each of you as an individual. Your initiative, your craftsmanship, your ingenuity, your precision. It is up to each of us to make every day count.
What Jack James' memo did not say was how hard it would be to reach Mars. Although JPL's Mariner 2 had been first to reach another planet, the spacecraft had barely survived the 3.5-month journey to Venus. Traveling to Mars would take almost twice as long. And nearer to home, 5 attempts in a row by JPL spacecraft just to crash land on the moon had failed.
The first thing we'll have to do is organize a team the best we can get. We're going to have to come up with a spacecraft design that will perform for at least 250 days outside the orbit of Earth and out to the orbit of Mars.
The first challenge was just getting there. What you did once you got there was kind of frosting on the cake. It was like climbing Mount Everest and planting a flag. It's not planting the flag that's important. It was just getting there.
The United States took great pride in having been first to Venus. It was an accomplishment widely acclaimed, from the Rose Parade to the White House. But the achievement did not automatically give JPL a green light to proceed on to Mars. The lab had to compete against a proposal by NASA's Goddard Space Flight Center in Maryland. Goddard wanted to land on the Martian surface. JPL's more cautious proposal was to replicate their success at Venus, launching 2 identical spacecraft to fly by Mars, with hopes that at least one would make it there. Ultimately, the choice was made for NASA when it became clear that the rocket the Goddard proposal required would not be available. Still, JPL's more conservative approach did not mean easy. Just reaching Mars was an enormous challenge. And JPL's mission to Venus had been with just a souped-up version of a spacecraft built only to reach the Moon. Going to Mars required a real deep space flying machine.
Mariner 4 was really the first spacecraft that were specifically designed for planetary exploration. Mariner 4 had all of the things that became characteristic of JPL missions after that. An integrated packaging and structural design, an octagonal bus, extensive use of louvers for temperature control, 3-axis stabilized, loaded with instruments that could articulate and point.
Traveling away from the sun meant encountering a colder, more hostile environment with less ability to draw power. The solar panels had to be more than twice the size of those flown to Venus. For the first time, the Earth could not be used for establishing the spacecraft's orientation, known as attitude control. Instead, these spacecraft would have to fly by sighting a star.
The spacecraft will roll, permitting the star sensor to search for Canopus. Once sighted, the gas jets will keep it locked on. It may be a very difficult operation, which will have to be backed up by ground command.
Because distances were far greater, communications links arrayed around the world had to be strengthened. What came to be known as the Deep Space Network.
Stations are so located that a spacecraft in deep space will be in direct line-of-sight contact with at least one of the stations continuously.
Above all, there was a very basic engineering concern. How long could a spacecraft withstand the harsh environment of space?
For one thing, instead of a 3-day mission, we were talking about a mission that was going to be 8 or 9 months. We went through the reliability analysis, and the number came out to be 30% probability of success. And we tended not to believe the numbers, you know. We sort of convinced ourselves that God did not really ordain that resistors should fail at, 0.0, whatever it was, percent per 1,000 hours. And we just plowed on.
The twin Mariners 3 and 4, which some dubbed flying windmills, were remarkable feats of engineering. But flying to Mars was only half the challenge. Just reaching Mars would be an accomplishment in itself. But the larger goal was learning what was there. For scientists, capturing even a glimpse of Mars as a spacecraft flew past might answer whether life existed there. It was a question very much on the mind of Caltech geologist Bruce Murray.
But you couldn't go to Mars on a camera. So a major development was finding some technology that could be used for a camera. So NASA chose a well-known physics professor at Caltech by the name of Robert Layton, a wonderful man, to set up the team and together design this first space camera system. In fact, it was the first digital camera of any kind.
After many meetings and a lot of give and take, we finally agreed that we should try to get a series of black and white photographs that should begin at the limb and continue across the planet to the shadowed area. The photographs should show detail at least 10 times better than any taken from Earth. Considering the altitude, angle of approach, possible resolution, and rate of sending back data to Earth, we designed the system to take 22 photographs.
On November 5th, 1964, Mariner 3, with the world's first digital camera aboard, lifted off from Cape Canaveral, Florida.
The launch is always exciting. It was even more exciting in those days because about half of them were failing.
And that was Mariner 3's fate. Within an hour of launch, telemetry showed that the mission was in serious trouble. For some unknown reason, the spacecraft's solar panels were not drawing power.
It had enough energy to escape the Earth, but not anywhere near enough to get to Mars. So it only lasted as long as the batteries could last. It lasted a few hours. It was kind of devastating news, but we were, to be honest, we were getting kind of used to that in those days.
The launch of Mariner 4 was now delayed while engineers worked against the alignment of the planets to understand what had gone wrong.
There were 3 weeks until Mariner 4 had to be launched because of this geometry between the Earth and Mars meant that you had to catch this window in time. So in that 3 weeks, JPL and the contractor figured out what had caused that failure.
The problem was tracked down to the nose fairing. Its purpose was to protect the spacecraft during launch. The contractor, attempting to reduce weight, had built it out of a light material that collapsed during ascent. Working around the clock before the launch window closed, engineers modified the fairing.
Clear to launch. We're counting engine start.
Remarkably, just 2 weeks and 3 days after the failure of Mariner 3, its twin was on its way to Mars.
Roger. 1 3 seconds. We're on our way. Roger.
Ahead was 7.5 months and 325 million unforgiving miles of travel through deep space. During the cruise, Jack James turned over the operation of the mission to Dan Schneiderman. He had been the spacecraft system manager for the mission to Venus. Schneiderman grew up on a chicken farm in Bakersfield, California. In World War II, he had worked in radar in the Aleutian Islands. Following the war, he used the GI Bill to get a degree in engineering. Then he got a job designing electric guitars. Unimpressed with the music most of them made, he quit and found his way to JPL.
He was a real character. And later in years, you know, I used to say, I would say in a group of people, I owe Dan everything I ever learned, I owe to Dan, or something like that. And he would get mortified. He would say, oh, Sonny, please don't say that. You know, he would wax philosophical. He liked to draw analogies, you know. I can remember him talking about resolution, what you can see with a camera.
It's interesting to look at things and look at them as you get closer. For example, if you go far away from, let's say, if you were an angel or something like that there, and you floated high above Southern California, you look down, you might see a greenery. See? And then you lower your altitude a little bit, and this greenery becomes patchy greenery. In other words, what looked to be homogeneous all of a sudden becomes random. Okay? You come lower, and all of a sudden what you're seeing is a single forest. So what was random becomes homogeneous again.
He was a worrywart, didn't sleep well. And he would say that the project is like a log floating down a river. All the people working on the project are ants crawling around this log, and the project manager is an ant at the front of the log, telling all the other ants to pull right, to avoid those rapids up ahead, or to pull left. And of course, whatever the ants do doesn't make a damn bit of difference. The log is going to go where the river takes it. I think it was expressing a sense of helplessness, that there's not much that anybody can do to influence the outcome.
Mariner 4's journey to Mars was relatively uneventful. The spacecraft at times had difficulty locating the star Canopus. That caused nervous moments when contact was sometimes lost. But only one trajectory maneuver was needed to keep the spacecraft on course, more or less.
In the beginning, when I first started, I was the trajectory engineer, so it was my job to design the flight path that would take the spacecraft from here to Mars.
The Mariner 4 trajectory, as it leaves the Earth and goes to Mars, will be approximately an elliptical orbit about the Sun.
We had not been to Mars with a spacecraft before, and as we were approaching the planet the last couple of hours, we realized that our estimates of the orbit were beginning to change significantly. In fact, we ended up missing by about 5,000 or 6,000 miles from where we'd aimed, which by today's standards is abysmal, but by those standards was actually not bad. The last hour to half hour before occultation was a wild scramble of trying to run orbits, trying to get the last data, trying to get on the phone and call Goldstone and tell him what time to turn on the tape recorders. It was a wild scramble.
This is Mariner Control Center at JPL. Mariner 4 is currently being tracked by Station 51, Johannesburg. The spacecraft is 134.217 million miles from Earth and 50,142 miles from Mars.
As the spacecraft neared Mars, everyone knew this would be an historic moment. And a white-knuckled one. A flyby of Mars meant a single pass and no second chances. Schneiderman and his first lieutenant, Bill Collier, were working a long list of what-ifs. A major concern was the star tracker. If Mariner 4 lost sight of Canopus, the spacecraft might end up facing away from Mars during the flyby, and that would mean having successfully flown for 8 months through deep space only to fail at the critical hour.
This discussion of Canopus, losing Canopus lock is meant to make a nervous man.
Oh boy, that just really scares you to death.
It does.
It really does. It just scares you to death. Because
if that hits us, we are really in trouble.
Boy, we're going to have a frantic day, no matter what time that might occur.
You're not the director.
While Schneiderman and Collier fretted, the science imaging team joked about what they might soon be seeing.
What are we going to do when we see H-E-L-P stamped out in the snow?
What John Cassani says we're going to see is a bunch of flack. These guys, these guys are going to be firing at us as we go by.
Meanwhile, the engineers considered more what-ifs. One was the spacecraft's primitive computer. It would be in control during the flyby. But if something went wrong, the computer had no backup plan. Should engineers leave well enough alone, or send up a new set of commands? That carried its own risk. New instructions might only confuse the spacecraft.
These are the questions, this is the soul searching you go through to, boy, don't worry. Our first reaction was, man, let that spacecraft perform for itself. Let's not horse around with it. But as soon as you start really asking these questions of yourself, then you begin to think, we can't take a chance. We've got to put ourselves in a position where we've done everything we can humanly do to ensure, or at least to enhance, the chances of success.
The main fear was that the tape recorder might not turn off. If that happened, the images would be recorded over following the flyby with the blackness of space.
If the tape recorder fails to turn off, we cannot tell that. And that's the rationale behind the transmission of DC-26, is to protect the pictures.
On July 14, 1965, another command called DC-25 was transmitted. With it, Mariner 4 began taking the first ever close-up pictures of Mars.
The DC-25 command should initiate a platform scanning action. If the command is not received, the spacecraft will initiate the scanning itself in about 1 hour. We expect that 21 pictures will be recorded. After other telemetry data are returned to Earth, the spacecraft will automatically initiate playback of the TV pictures.
The first picture will cover an area of approximately 176 miles square on the sunlit limb of the planet.
I wish I were as sure as he is.
About 12 minutes from now, we should be able to determine that the TV camera shutter is operating and that the recorder is running, although we will not be able to determine definitely whether pictures are actually being recorded on the tape until they are played back.
It's time for 26 to go.
26 was DC-26, the command for the recorder to stop taking pictures.
There it is.
The system had worked. The picture was recorded on board the spacecraft. That was a big deal.
Gee, it's not safe to say that's the only thing, because we're really subject to
just say everything is okay.
almost anything could occur.
Okay, good. I'm going to go get some lunch here. I hope in about another 15 or 20 minutes.
I just hope nothing unusual happens. I hope it keeps right on being just as easy as it's been so far.
Yeah, that's what I want to do.
Later, Mariner 4 transmitted back a conflicting message. The tape recorder might not have worked as expected.
There were some extra events that came back via telemetry. And if you read those events in a certain way, it said the tape recorder had stopped recording. And that caused great panic among the management here.
Yeah, what about the tape recorder?
Well, the tape recorder, the answers that I got late here is that we got a normal first end of tape and a normal second end of tape, and it appeared as though that the second end of tape switched the data encoder to mode 2, just as it is supposed to. But the answer here, the last I heard there, was that there was some funny business in the first 10 picture recording.
That TV system, which should have turned the tape recorder on and off, may have failed to turn it off. And the tape runs through faster. And that was exactly the reason we sent this command 26, was to save as many pictures as we could on the tape. So we don't know for sure it's happening.
The actual time of transmission of DC-26.
Mariner 4 carried other science instruments. And those measurements were programmed to be transmitted back first. Only later would the pictures come, if there were any.
The data came back extremely slowly from deep space, went into the Goldstone tracking antenna out in the middle of the Mojave Desert, and came to JPL by teletype. It was that slow. Click, 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 click.
Chunka, 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 chunka.
The data playback rate was only 8 1/3 bits per second, which is, as Jack James, the project manager at one time said, it was a slow Morse code. And so it would take hours to get each individual picture back. So it was going to be days before you got all the data back.
8 days, in fact. This did not sit well when announced to the restless press assembled at JPL.
The performance of the spacecraft during the picture-taking sequence was not precisely as predicted. There were some anomalies, and we have attempted in this short period of time to diagnose these anomalies. We are still optimistic that we did indeed take some pictures. We have always said that we cannot determine whether or not these pictures have been taken, even when the system performed correctly, until tomorrow morning, when the picture playback sequence will be initiated.
And this was a time when life on Mars and Mars was a very exciting thing. There were only 3 major networks in those good old days. They were all sitting in Von Karman Auditorium, getting very restless. They came to get their story, and they kept saying, "Where are the pictures?" Well, they're working on it. And so they began to get pretty nasty, demanding that this is the public's money, these are public statements, which is true. Why can't we see them? Well, the answer was there wasn't much to see.
Difficulties in this business is that it's such a difficult game that your experience really tells you that almost anything abnormal usually spells disaster.
After what seemed an eternity, Mariner 4 began transmitting back images, assuming that was what was actually stored on the tape recorder. The pictures were to come back in the form of 1s and 0s, each number representing a shade of gray. The first numbers transmitted corresponded to black, as was expected.
So, they may be all black, but we got some there. Hey, there we go. There she goes. Yeah, that's data.
Based on your preliminary analysis of this data, can you describe what you see on Mars?
Yes, it's there.
That wasn't fair.
Well, congratulations to you both, as a matter of fact.
Let's see what the picture looks like now.
Yeah.
Oh, boy.
Give me Bruce Murray's phone number. We're the devil or the Mars picture interpreters. Yeah. Data's coming in, boy. What are you doing in bed? You didn't, huh? Well, the numbers are coming in hot off the line. First, well, yeah, okay. Shave, at least.
The processing of images was far too slow for some. Desperate to see Mars, engineers took matters, or in this case numbers, into their own hands.
2 or 3 of us who had worked on the tape recorder came up with these schemes of how to try to sketch out the data in real time as it came in. And it was kind of a contest. And the one that won was essentially our adding machine paper tapes tacked to a wall. And that's the one that allowed us to kind of look at the data in real time.
And we created an image that way on paper faster than they could reconstruct the picture in a computer.
That first picture was from us engineers trying to figure out if the tape recorder was working because our bosses were saying, what do we tell the press? That's where the big pressure was. And at the point where some people noticed we were starting to put a picture together, they put a guy in charge of security to keep people away from the door. But people kept wandering in, so the word was spreading. Some people wanted to stop us from doing that because we would circumvent the PR release of pictures, if any. We said we're interested in the engineering and not the pictures, so they allowed us to continue. We then had enough fans collecting, and our immediate bosses said, keep going.
Get in there dancing. Is this the first time you've seen that? No kidding. Hey, that's gorgeous.
As you know, the more formal processing of these pictures is taking place.
Dr. Layton from Caltech came in and looked at it. He really understood the data. He quickly picked up that the darkest of our numbers was actually the black of space, And he said, there's the limb, and he could start to look at the picture, and he looked like a happy camper, so. It's been a lot of fun because it was accidentally kind of the first picture of Mars.
Eventually, the first real close-up picture of Mars was processed. It was brought into the imaging team's inner sanctum and laid in front of the scientists, face down. They were shocked by what they saw, or what they didn't see.
Everything was kind of very secretive. I'm not sure I exactly know why. There were only about 5 people on the imaging team, and somebody came running over to get me because I had also developed a software program that would predict exactly where the first picture would be taken and where each of the subsequent pictures would be taken on Mars. And so they came over, and I had to go over to this little room, and I knocked on the door, and the door opened. They grabbed me and pulled me in, and they said, "What does the first picture supposed to look like?" And I said, "Well, I don't know." But they said, no, I mean, is it going to be on the planet or off the planet? And I said, well, it should be about on the limb. It should be about half on and half off. Oh, good, thanks, goodbye. Out the door I went. I think they were a little concerned that the first picture that popped up only had part of Mars in it, you know, but that's the way it was supposed to be.
The lay public was very interested in the photography that was coming back from the planets, which had been just points of light, and now we were discovering that they were worlds in their own right. For a while, the WAGs said JPL stood for Just Pictures Laboratory because imaging was such an integral part of most of our missions.
JPL had learned with its missions to the moon that pictures mattered. And now President Lyndon Johnson wanted to see Mars. A White House briefing for Johnson and the passing out of medals also afforded the opportunity to underscore to the world another U.S. accomplishment in the race for space.
I think I speak for every American when I tell you how very proud and how impressed, how grateful we are for what you and all the many members of your team have accomplished on the Mariner 4 mission. It may just be that life as we know it is more unique than many have thought.
Johnson's comments about the uniqueness of life were referencing these first close-up pictures of Mars. However fuzzy, they revealed a Mars far different from what had been expected.
The best pictures showed a cratered surface which had to date back to 3 or 4 billion years old. And that was so at variance with what we expected that everybody was very shocked.
The Martian surface was ancient. There were no signs of mountains, no canals, no flowing water, and no vegetation. Any hope of life on the surface was gone. At the beginning of the space race, JPL had proposed to NASA an ambitious plan to send an armada of spacecraft sweeping across the solar system. Now JPL knew how hard it really was to reach another planet. Yet in a reversal of roles, NASA was now pushing for bold missions. The agency wondered, might the massive rockets needed to launch astronauts to the moon be used for robotic missions to the planets?
The idea gained favor in NASA headquarters that the next mission would be a Saturn V to Mars. And that meant that the 575 pounds that we were able to send in Mariner 4 would be succeeded by a 50,000-pound payload in one leap. Now, this is insane.
2 large spacecraft with entry capsules, 2 of them, all sat on top of a big Saturn V. It was monstrous.
Orbiters would circle and map the planet in detail, while landers would search for life on the surface.
It was very fortunate for all of us and everybody that that thing got canceled.
These were to be mere precursor missions. Astronauts, NASA dreamt, would put their footprints on Mars in the late 1980s. In 1969, 2 mariners numbered 6 and 7 managed to survive their launches. For the first time, JPL was flying 2 spacecraft to the same destination. The Soviet Union had the same idea, but both of their missions failed during launch. Following a 5-month cruise, the mariners were fast approaching their destination, and excitement among the engineers was building.
It's just great. It's like being on the bridge of the Starship Enterprise. Only that didn't exist yet. You can place your mind where you think you're in the spacecraft, and every command you send to the spacecraft, you can imagine what it's doing. I'm out there in the darkness of space with the spacecraft, and I'm seeing, just like the camera is seeing, Mars hanging there, and that's our destination. We're going there.
50 hours before closest approach, Mariner 6 turned on its science instruments and cameras.
Oh, geez, that's great. Is the lighting halfway decent?
Only 9 days before, Neil Armstrong and Buzz Aldrin had landed on the moon. But in Pasadena, there was no time to celebrate. Mariner 6 was already beaming back data. And following right behind was Mariner 7. Advances in technology had greatly improved the turnaround time for pictures. Instead of sitting in a back room, Robert Layton was now at a TV console, offering to the world instant reactions as images of Mars reached Earth.
I see the picture developing here. So here's our first view of Mars since Mariner 4. I see some interesting light areas near the upper limb. There are some bright areas near the afternoon limb, the upper limb of the planet, as you see them on the screen there.
Compared with pictures, a science instrument on board the spacecraft called an infrared spectrometer was easily overlooked by the public. Its purpose was to measure the chemical makeup of the Martian atmosphere. With this instrument, it might be possible to detect evidence of life, if it existed, in the form of methane. On Earth, this organic compound can be produced by microorganisms. Finding methane on Mars would be a scientific discovery carrying tremendous implications. But there was a conflict. The TV cameras and the infrared spectrometer were mounted on the same scanning platform, which meant both had to be pointed in the same direction. Scientists were at odds about where and when to aim.
The value judgment in this, and also for 7, is what indeed you see in the dark side. As you point out, none of you have seen it. You don't know. So that could be the most exciting thing of all. If there's an elevation difference
this could be the most exciting, and that's the place where we'll get the best information on both flights.
I think you failed to appreciate the point I was trying to make, is that you're costing us 8 pictures on the bright side of 7.
Oh, come on.
Just a minute. Listen, hear me out. Just a minute. Hear me out, please. Because the argument is canonically the same kind of argument. You don't know what you're going to see. Bob is unimpressed with what you're going to see there. I am too.
I was unimpressed with what we saw last night, but I think you had to look.
Just a minute. Let me finish.
I think the issue that now is opened is whether you should look again. Because you know at distant encounter you don't see it, but you're going to want to look again.
May I finish, please? My point?
We haven't got much time.
This debate was an early example of what would become a classic dilemma for scientists. Multiple instruments on a spacecraft often meant conflicting desires. And not every hope could be fulfilled, especially with flyby missions lasting only a few hours.
So 2 degrees south, 3 degrees south, 1 picture longer. Right.
These scientists had invested years preparing for this mission. For some, their professional careers were at stake. The expectations, especially given time constraints, were enormous. This was especially true for George Pimentel of the University of California at Berkeley. 2 years before, he had come close to becoming one of NASA's first scientist astronauts. His dream was to go to Mars. But Pimentel failed the agency's stringent physical exam due to a minor vision problem. Now he was determined to go to Mars in another way, through his science instrument. A maverick, Pimentel had already clashed with JPL engineers over technical standards. He was not averse to conflict. Lore has it that when a JPL quality control engineer once visited Pimentel's Berkeley lab, a fistfight had broken out. And now at this critical hour, for some unexplained reason, his spectrometer on Mariner 6 had partially malfunctioned. Some data was captured. It seemed to indicate a remarkable finding: water in the form of ice at the South Polar Cap.
Ice? H2O ice? Yeah, right.
You really think you got water ice, George?
Pardon me?
You really think
There's no question about it being ice.
Finding water in the form of ice, if true, would be a huge discovery. But everyone else's attention was soon drawn elsewhere.
The encounters were not very far apart, just a few days. So we had 2 spacecraft to monitor, and it turned out that while the first one was in the encounter phase, we had some emergencies on the second one.
So we were taking pictures during approach. We were in the middle of our approach sequence, and somebody says, "Hey, Mariner 7 disappeared."
Without data, we're kind of a little bit blind.
When contact was reestablished, engineers were stunned to find that something had caused Mariner 7 to go cartwheeling through space. But what?
Just stand by and keep looking, and 11, if you see a signal, call it out, and we'll see what we can do.
I don't want to discourage you, but they may not see it because of degraded noise temperature.
Amazingly, engineers managed to regain control of the crippled spacecraft. But what had caused the disruption remained unknown.
So it was a very hectic time, as I remember, in trying to handle the very complex operation on the first one, along with the emergency on the second one.
Well, you know what the problem is? Just unscramble the data.
A possible cause was Pimentel's troublesome spectrometer. It required a pressurized canister of coolant gases. A container explosion would explain Mariner 7's near-catastrophic event. As the second Mariner bore down on Mars, Pimentel's instrument became the prime suspect.
No, the JPL people are the ones who think that something went wrong with our gas system. The problem is there's no probable theory as to what could have done what has apparently happened to it. And
are these all enhanced?
So there's a natural tendency to look at our gas bottles because they're capable of doing a lot of damage. Yeah. Well, after Mariner 7 arrival, I may want to go to Russia.
Just before final approach, engineers commanded the spectrometer to turn on and cool down.
The real moment is when we see what happens when the signal to start cooling down the IRS occurs, right? That's and we'll see whether whose prediction was right.
If the spectrometer failed to cool, engineers would have their smoking gun.
It's time. It's past now. We ought to hear DC-49.
Reports from Mission Control appeared to be good news for Pimentel.
That's number one. That's big news. That's the squibs got current.
Got current? No.
Well, he said
the event.
It's just a logic thing. Correct. We do not see significant effects on normal cycles as we would not expect. We would expect to see disturbances. And you do not. Correct? We do not.
If what?
That's the attitude change has no control.
You mean they think it didn't, the bottles didn't go?
That's fact. Attitude control reports no effect from the pyro event.
That's not nice.
That's what's known as bad news.
Yeah.
If we don't hear something in a couple of minutes, we've had it. Yeah.
Oh, it was Puerto Rico. I can't stand it.
God, you're testing it.
Whoa!
Yes, 3 minutes. 22, 23, 23. What's the IRS? The Channel 1 detectors called. It's reading. Varying spectral data on Channel 1 or Channel 2. Minus 480.
Lester!
No, wait a minute, it's like a break. That would be short.
While a relieved Pimentel celebrated his instrument's innocence, Leighton continued sharing aloud possibilities about what he was seeing.
What a view, huh? What a view. Say. Incidentally, I think a view like that must convince one that that deposit on the polar cap must be more than a fraction of a millimeter or
Was the southern polar cap made of water as Pimentel's instrument had indicated? Or were these layers of carbon dioxide, dry ice? For anyone hoping to find life on Mars, water was the preferred answer.
We'll be back tomorrow at 5.
Pimentel, with data in his hands, departed for home to pore over the measurements. Later from Berkeley, he took part in a conference call in preparation for a press briefing. A teasing Pimentel hinted of a blockbuster announcement.
I'm curious, was that a hint that you think you're seeing something organic?
Oh, yeah.
You think you are?
Did you say you're curious or furious?
Curious.
Well, sure. That's our optimistic hope right now.
Organics meant the possibility of life on Mars.
Quiet down there. Quiet up here.
What are the wavelengths of your organic bands?
We'll see tomorrow, Don.
You don't want to tell us now.
Right. I can say you can just picture the planet teeming with life. That's supposed to be a joke.
Yeah, I know.
Pimentel's teasing left the others not only in the dark, but deeply puzzled. All the other science results pointed to an entirely different conclusion. And at the JPL press conference, one scientist after another presented a picture of a barren, lifeless Mars. Until the last speaker.
We were up, Dr. Herr and I, almost all night last night with our computer trying to analyze our data, and I'm telling you the results as our instrument indicates. And insofar as we may later prove to have to retract something or not, that's the nature of science. I'm telling you what our data indicate. We are confident that we have detected gaseous methane and gaseous ammonia on Mars.
Being confident of having found methane was all but another way of saying there was evidence of life on Mars. But Pimentel was not done. His instrument also pointed to that key ingredient needed for life, water.
Our data are consistent with and suggest that the polar cap is composed of water ice and probably not solid CO2. In the region near the edge of the polar cap, polar ice provides a reservoir of water. The solid carbon dioxide cloud provides protection from ultraviolet radiation, a region certainly deserving further exploration.
Thank you, George. I think you can all see why science is fun.
As Pimentel had cautioned, the nature of science is that knowledge is subject to new findings. He, like others, had rushed to share results virtually overnight with a public eager for instant science. But responding so quickly was risky and ran counter to the science tradition of critical review. And Pimentel and the others took other chances in allowing cameras to witness science in the making, warts and all. Very few scientists in the years since have been so transparent. In Pimentel's case, he soon realized one of his findings was flawed. The spectrometer had not distinguished between methane and CO2. He quickly and publicly announced the error. And with that, life on Mars was once again an unsolved question. As for the mystery of what had gone wrong with Mariner 7, an investigation traced the probable cause to a battery explosion. Mariner 6 and 7 had imaged nearly 20% of Mars. Piece by piece, the planet was beginning to be known. The ice caps were made of water ice, not carbon dioxide. The most discouraging discovery for those hoping to find life was learning that the sun's lethal radiation was reaching all the way to the Martian surface. And once again, there were images of craters, but for some reason, not everywhere. Mars seemed deserving of another look, and more so than anyone realized. By sheer chance, the paths of the twin mariners had not taken them in sight of two gigantic geological features, the largest of their kind in the entire solar system. The first great engineering challenge in robotic exploration was to fly by a destination for a brief glimpse. The next feat was to build a machine capable of going into orbit around a planet. In 1971, the very next opportunity to go to Mars, JPL had taken the idea of an orbiter from the drawing board to the launch pad.
The basic spacecraft was pretty much pure Mariner, but it had this humongous propulsion module on it to slow the spacecraft down when you got to Mars to the point where it could be captured by Mars gravity. That presented some interesting challenges. You had to store propellants in space for 9 months and then use them and cross your fingers and hope that everything worked the way it was supposed to.
Once again, the spacecraft were built in pairs. It was prudent planning. For yet another time, the first mission failed when the upper stage rocket malfunctioned.
This is Kennedy Launch Control. It appears from our preliminary data here in the Mission Directors Center that the Mars Mariner mission has not succeeded. We are standing by for further reports. This is Kennedy Launch Control.
Mariner 9 had better fortune and smoother sailing to Mars. And this mission was not flying alone. Just behind it were 2 Soviet probes. These spacecraft were orbiters too, and the Soviets were raising the stakes. Hitchhiking aboard each spacecraft were landers equipped with a TV camera, science instruments, and a small shoebox-sized rover. All was well with all 3 spacecraft as they neared the halfway point of their journey. But then Mars itself began behaving in unusual ways.
We were going to arrive in November, and in about August, the Earth-based astronomers said something funny is going on at Mars, and within a week or two, there was a global dust storm on Mars. You know, when you normally look at Mars, you can see lots of dark and light features and so forth through a telescope. It looked like a billiard ball. We were now at August. We were like 2.5 months before encounter. You know, we didn't know what to do. I mean, we were beginning to feel a little bitten, I think. We'd lost Mariner 8. We'd gotten everything loaded into Mariner 9, and now the planets disappeared on us.
As the dust storm swirled, the 3 spacecraft, 1 American, 2 Russian, continued on their way. On the evening before Mariner arrived at Mars, Bruce Murray arranged a symposium at Caltech. Called Mars and the Mind of Man, the panel featured scientist Carl Sagan, journalist Walter Sullivan, and science fiction writers Arthur C. Clarke and Ray Bradbury. Murray labeled himself the realist of the group, the one doubtful that Martian life might exist.
So I became, in these debates within the scientific community and sometimes in the public community, the bad guy, the black hat.
Man as a human species has been guilty of wishful thinking collectively, that we wanted to be like the Earth, and that this is a very deep-seated desire to find another place where we can make another start or it could be somehow habitable. And it's been very, very hard to face up to the facts which have emerged and have been emerging for some time, that it really isn't that way, that it is just wishful thinking.
If Murray was the realist, a buoyant Bradbury was a jubilant optimist with a poetic message.
I don't know what in hell I'm doing here. I'm the least scientific of all the people up on the platform here today. A 10-year-old boy a few years ago ran up to me and said, "Mr. Bradbury?" I said, "Yes." He said, "That book of yours, The Martian Chronicles?" I said, "Yes." He says, "On page 92, I said, "Well," he says, "where you have the moons of Mars rising in the east?" I say, "Yes." He said, "No." I was hoping that during the last few days, as we got closer to Mars and the dust cleared, that we see a lot of Martians standing there with huge signs saying Bradbury was right. Or even Clark. And I have brought along today, I'm going to keep this short because I'd much rather listen to our scientific friends here today tell us about what's coming up this week. But every time I get a group of people together and have them trapped in a hole like this, I bring a poem, see? And you can't escape me. But luckily it's a short poem, but it sums up some of my feelings on why I love space travel, why I write science fiction, why I'm intrigued with what's going on this weekend on Mars. And part of this has my philosophy about space travel in it, and if you'll permit, I'll read it to you. It's very, very short. The fence we walked between the years did balance us serene. It was a place half in the sky where in the green of leaf and promising of peach, we'd reach our hand to touch and almost touch the sky. If we could reach and touch, we said, 'twould teach us not to, never to, be dead. We ached and almost touched that stuff. Our reach was never quite enough. If only we had taller been and touched God's cuff, his hem, we would not have to go with them who've gone before, 1 billion, give or take, 1 million boys or more, who, short as us, stood tall as they could stand and hoped by stretching tall that they might keep their land, their home, their hearth, their flesh and soul. But they, like us, were standing in a hole. Oh, Thomas, will a race one day stand really tall across the void, across the universe and all, and measured out with rocket fire, at last put Adam's finger forth as on the Sistine ceiling, and God's hand come down the other way to measure man and find him good and gift him with forever's day? I work for that. Short man, large dream. I send my rockets forth between my ears, hoping an inch of good is worth a pound of years. Aching to hear a voice cry back along the universal mall, we've reached Alpha Centauri. We're tall. Oh God, we're tall. That's all.
Mariner 9 became the first spacecraft ever to orbit another planet. Following right behind were the two Soviet orbiters with their landers aboard. The landers, designed to be released just before orbit insertion, could not wait for better weather. They would be plunging into the Martian atmosphere in the midst of the largest dust storm ever known to have occurred in the solar system.
And for them, it's much more serious than losing a few mapping pictures, because if they have to come in with wind velocities of many hundreds of miles an hour on something which is, has some aerodynamic braking or a parachute system, and they have only a certain acceptance cone that their communications can go back, you know what I mean? The Earth is up there in the Martian sky, the spacecraft is falling in. If you have strong winds and the thing is swinging like some pendulum or tilting over, then they potentially can have very serious problems.
Carl Sagan proved correct about his concerns. Whether caused by the Martian winds or something else, the first Soviet lander crashed onto Mars after its parachute failed to open. The second descent module succeeded in landing. But less than 20 seconds after touchdown, the lander went silent and was not heard from again. The tiny rover on board never had a chance to move even an inch. But the lander did manage to transmit 79 scan lines of video. Some consider this the first image, however incomplete, from the surface of Mars. Though the landers failed, the Soviet Union did succeed in putting two spacecraft into orbit. The space race was far from over. Eventually, the dust storm that had draped Mars subsided. What the planet was finally ready to reveal to Mariner 9 was more than worth the wait.
It was a kind of epiphany in the sense of what an orbiter can do versus a flyby. The previous two flybys, Mariner 4 and Mariner 6 and 7, all three of them had flown by, and it was just coincidentally, they'd all flown by the same side of Mars. They'd flown by the uninteresting side of Mars.
And when the dust cleared, we found a planet that was completely unlike the one that Mariner 4 had seen and that Mariner 6 and 7, completely. And so this planet, which we had labeled as like the moon, suddenly looked like the Earth, except in gigantic relief. Bigger volcanoes, bigger flood channels, a canyon that runs the distance of the United States across and is 60 miles wide in places and 6 miles deep. The Grand Canyon of Arizona would fit in as one little tributary off the side. So we got really zapped because not only was it Earth-like, but everything was larger than the Earth. So that left us bewildered geologically, but the people who were interested in life on Mars were ecstatic because clearly there had been an aqueous phase in this planet's history.
Mars had yet again revealed itself in a very different way. It was now known to be a geologically dynamic planet, forcing Murray to reconsider whether life on Mars might still be possible.
The consequence of discovering these huge channels in this larger-than-life Earth-like planet out there was to renew hopes that there really is life there and that the original dream, going back to telescope days, could be realized.
Now there was yet a new reason to go back. Not to fly by or orbit, but to land and search for life. The first challenge in planetary exploration was to fly by a planet. The second was to go into orbit. And still to this day, there is nothing harder than the third: landing. Touching the surface of Mars was now the next great engineering ambition, which was more than matched by a dramatic science goal: to search for evidence of Martian life. To the consternation of JPL, it was not chosen to lead this prized mission. The reasons were many. Relations between NASA and JPL were often strained, and the agency believed the lab had its hands full with other assignments. NASA also wanted to spread the wealth of work to its centers. Besides, the Langley Research Center in Virginia had an impressive record in sending spacecraft to reconnoiter the moon. Key to Langley's success was project manager Jim Martin. He was known to be as tough as he was successful. He cared little of title or rank. What mattered was performance.
He was 6'4", 6'5". He looked like a commander. He stood up strong with his huge barrel chest. He had a gray flat top. His eyes were taking in everything all the time, and you expected him almost to bark.
This is Launch Complex 41, from where the Viking missions will be launched on the Titan Centaur launch vehicle.
The New York Times had a big story on him right after Viking, which they likened him to a Prussian general. And to people who did not know him, who did not see his softness, he did not suffer fools.
With Martin in charge, Langley had overall responsibility for managing the project that was named Viking. The aerospace corporation Martin Marietta won the competition to build the two landers. Their arms were to reach down and scoop up soil samples to be examined in an onboard lab for signs of life. JPL's role was to build the spacecraft that would ferry the landers to Mars, relay information from them back to Earth, and conduct orbital science. Given the lab's expertise in navigation and communications, operations would also be conducted out of JPL's mission control. All told, Martin's Army was a massive operation spanning the nation, requiring 8 years, more than 10,000 people, and the largest budget yet then spent on a planetary project.
The team that actually flew the mission was a badgeless team. Our badges said Viking. They did not say the Martin Marietta Corporation, NASA Langley, the Jet Propulsion Laboratory, or any of the many subcontractors. There was an allegiance throughout the team to Viking.
Martin took a special liking to Gentry Lee, a young Martin Marietta engineer whose style of dress and length of hair ran counter to the culture of his employer.
I was 28 years old. My hair was down below my shoulders and had little curls at the bottom of it. I wore white jeans with strawberries scattered all over them. And I once went to one of these monthly reviews wearing a pink shirt. And the chairman of the Martin Marietta Corporation at that time happened to attend that particular meeting. And he asked Jim Martin, "Who is the kid in the pink shirt and the strawberry jeans?" And Jim Martin looked at him and said, "Well, he's one of yours."
Gentry Lee is a different individual. One of his big bosses told him his hair was too long and he'd never get any place with long hair. Gentry was a guy that could decide for himself how long his hair wanted to be. So as a result, he went to work for JPL. He's probably one of the brightest people I ever encountered.
What we actually have to do, it's becoming clear as we learn more about Mars, is press all the way back to the beginning of time and go through the geological evolution, the atmospheric evolution, the interaction of the two. At somewhere different kinds of molecules form, and at somewhere they may become life and so forth. So that's the sort of thing, in general, that I'd hoped we would talk about.
Well, I hope you'll be glad to know that for this complete survey of all of human knowledge, considering all of the planets, we have allowed you half an hour.
Okay, and
Martin made Lee a key player in the mission, assigning him the role of coordinating science analysis and mission planning. That meant leading the science team to consensus. It was like herding cats, one person said. Very smart, but very independent cats.
I had all the scientists and all the mission analysts under me, and as I often tell people, I had 2 Nobel Prize winners and 4 who took me aside and explained why they should have won the Nobel Prize. It was quite a group. It was quite an adventure.
There were other jobs Martin gave Lee, including running political interference. One assignment was explaining to a White House official, oblivious to planetary alignments, why delaying a launch to Mars required 2 years rather than 1.
I get this guy who announces he's some big muck-a-muck in the White House, and he's clearly irritated. He says, if I want to take a bus to Alexandria and I want to delay for a year, I delay for a year. So why can't you go to Mars 1 year later? And I said, well, it's the way the planets are set up. And I don't think the president has the power to change that. There was quiet on the other end of the phone, and he says, are you a smart ass?
In 1975, the 2 Vikings lifted off the launch pad. And just as the laws of physics dictated, 10 months later, they were nearing Mars. And having learned from the Soviet misfortunes with the dust storm, the Viking landers were designed to be released at the time of the mission's choosing, after going into orbit.
Viking very cleverly is to carry the lander into orbit and not have to drop it for a period of more than a month. I mean, you see, Viking will be able to pick its places very nicely.
Being able to choose not only where, but when to land offered a huge public relations opportunity. The 4th of July in 1976 would be the 200th anniversary of the Declaration of Independence. What could be better than to celebrate America's bicentennial than landing on Mars? That was the expectation. And as scheduled, Viking 1 went into orbit and began sending back images of the proposed landing site. What the pictures revealed was a shock.
We got into orbit around Mars, everybody celebrated, and on the 3rd periapsis, we took photographs of our landing site. So the first time we spread out these photographs, we looked at where we had thought we were going to land a priori, and I remember Mike Carr and Carl Sagan and Hal Mazursky and Hugh Kiefer and I just eagerly sitting around the table looking at the pictures, and then I heard, uh-oh, that looks like an outflow of river channels and there are going to be boulders there. And then Jim Martin strode up and said, and what does it look like? I said, looks bad. Looks bad? He turned to me, he said, plans A and B go into effect immediately. That began 18 days of what's the next option? What's the next option? That's not a good place to land. Where do we go now? What photographs are we going to take tomorrow? And finally, with that second Viking coming in, we were getting to the point where our nerves were strained. The hardest job of all this, though, was the job of telling President Ford that we were not going to land on July the 4th. So I looked at Jim, and I said, well, Jim, he said, I got it. First, of course, he had to call the NASA administrator who tried to talk him out of it. And Jim said, well, he said, I'm going to tell you something, sir. If we land there, I'm not responsible. There was quiet on the other end of the phone. He says, I'll call the president.
Well, I am disappointed, as are many people, but yet we've always had in the back of our mind the fact that Mars might not cooperate. And I guess I would say it has not.
It was not the only time that Martin would disappoint Washington.
An hour before the landing, I received a phone call from the White House.
We were in the middle of the lander checkout prior to separating the lander from the orbiter, and then prior, of course, to the lander's descent and subsequent landing. Jim was in his office, which was kind of a glass cage in the middle of the flight operations area. The voice on the other end of the line says, "Mr. Martin?" "Yes." "Mr. Martin, this is the White House calling. You tell President Ford, please, that I do not have any time to speak to him right now. We're in the middle of a lander checkout, and for him to call back in 3 hours."
The administrator was sitting in my office at the time. He said, "Did you tell the White House you were too busy to talk to them?" And I said, "Yes, because I am too busy. Right now is absolutely the wrong time. Look at everything that's going on." He said, "Well, I understand, but that's the White House." And I said, "I'm sorry. You know, this job of getting the mission down on the surface is the most important thing in my mind."
In 3 hours, President Ford called back. Now, for those of us who'd worked for Jim for 8+ years, it was a no-brainer. Of course the president was going to call him back. Jim told him to.
In the early morning hours of July 20th, 1976, the Viking 1 landers separated from the orbiter and began the descent to the Martian surface.
We've sent 0.05 Gs.
Telecom lead, how's the SNR and high rate?
SNR is holding very well.
In the atmosphere now.
All days dropped.
UHF minus 106.
Now you have to realize this was before anybody knew about onboard software, closed-loop guidance. It had to do a parachute.
Water fire. The chute has been deployed.
Format 3 is in sync.
Then it had to do a terminal descent with its radar, its 4-beam radar working, and land softly. It had to go from 10,000 miles an hour to between 2 and 3 miles per hour in just a few minutes, and it had never been done before.
2,600 feet. 1,200 feet, 140 feet per second.
So the engine started.
0.6 Gs. 20 feet, 366 feet, 73 feet per second. ACS is close to vertical.
So we're coming down, straight down.
Nav is green for touchdown. ACS is green, 1.5 degrees per second max, 0.2 Gs.
Touchdown, we have touchdown. We're looking good.
We knew it had sent the message. It had survived at least momentarily, but then we had to wait 40 minutes for the orbiter to play, return to the Earth, and play the lander data back.
There's the first piece of information coming in.
A moment in every Viking's life that he or she will never forget is sitting with that television right in front of them and watching as the first lines came down. It came down line by line by line.
Oh, more, a few rocks.
Oh, that's beautiful.
The first photograph that a human being has ever seen from the surface of another planet.
Yeah, I'm supposed to say something at this point. I just don't feel like talking. It's just incredible to see that the Mars, is really there.
And we all, 5 billion people on the planet Earth, saw Mars for the very first time.
Look at the beautiful rocks. Fantastic. And all of a sudden, we were looking at the surface of Mars, and it was clear, it wasn't dusty. And when we got to the end of that first picture, with the dust and small pebbles in the footpad, it was just, it was really a miracle.
Images that came down in the following days revealed that the mission had been as lucky as skilled. There were rocks and boulders everywhere.
You see this big rock out there called Big Joe. That was about 25 or 30 feet from the lander. If we had hit that rock, the lander would have been smashed. The lander found its way to the surface in a very smooth spot and avoided the rocks. We had no hazard avoidance whatsoever, just a lot of luck, if you will.
It never occurred to me that we really might fail. I got those butterflies in my stomach, but we didn't know then what we know now, which is how tough it really is to land on Mars. And the other thing we didn't know is that we were surrounded by the best and brightest engineers you could possibly find. The best and brightest from Martin Marietta, the prime contractor who built the lander, the best and brightest from the Jet Propulsion Laboratory who built the orbiters, the best and brightest NASA had at NASA Langley and other places. They ran the mission, but mostly we had become a team. Jim Martin skillfully, over 5-6 years of time, picked the very best he could find in every spot. And so later on in life, we would look at each other and we'd say, my gosh, weren't the people on that project smart? And we didn't realize that this had all been orchestrated for us.
Now, safely on the Martian surface, there was time for a call from Washington.
Hello, Mr. President. Jim Martin and myself are on the line.
Nice to talk to you, Jim Martin.
Thank you, sir.
Congratulate Dr. Jim Fletcher, the administrator of NASA, and you, the Viking project coordinator, for the just wonderful and most remarkable success in this historic mission. And I strongly encourage all Americans to follow the progress of our Viking missions and to reflect on our journey into the unknown. Do we have any plans for Viking 3, etc.?
Mr. President, we're thinking very hard about that right now. I just got a big bunch of applause from our team here on that question.
Well, I suspected that there might be approval among all of you for such a landing and such a project. And
well, Mr. President, the team is ready for Vikings 3, 4, 5, and 6.
Well, give everybody my very best, will you? And let me express to each of you and all of the group my very best wishes for a great job. We're all very proud of you.
We appreciate those kind words, Mr. President.
Good luck.
Mr. President.
Bye.
Goodbye.
Thank you.
The enthusiasm for more Martian missions proved wishful thinking. Although Martin's team had achieved an enormous engineering feat in the successful landings of both Vikings, the primary science mission, the search for life, was inconclusive at best and discouraging for many.
Not just that there was no life, but there was no organic material, and that found out the explanation was that Mars is self-sterilized. Nobody expected that. I didn't. No one did.
But circling over the landers were the Viking orbiters. They provided 6 years of continuous monitoring of Mars and once again changed our understanding of the planet. Here was a planet not only of craters, vast trenches, and giant volcanoes, but also what appeared to be great river valleys carved out by massive amounts of water. At some point in the past, the surface must have been warmer and wetter. If so, what had happened? Mars was more mysterious than ever. But to the dismay of many, interest in future missions began to dwindle.
I've talked to a large number of the scientists in this program who are unhappy that, in their view, the space agency has no follow-on program for Viking at this time. Is it true? Why is it true?
I think that that the planetary program must get a new infusion of adrenaline, or it will die a death through neglect.
JPL was worried for the same reasons. Having Viking operations conducted out of the lab's mission control had been a great windfall of public attention and, at times, misplaced credit. But the outlook ahead seemed bleak. NASA's budget was under severe pressure, and the pipeline for future planetary missions was reduced to a trickle. As for Mars, the United States would not return there for 2 decades.
This is an example. It's a bit of the Martian weather that we've reproduced for you. No, it isn't snow, it's a different kind of weather that scientists have predicted that we may find on Mars. This is the theory. If the Martian atmosphere contains carbon dioxide and methane, and they are exposed to the ultraviolet radiation of the sun, they may produce sugar. In other words, there may be a constant sugar fall on Mars.
We know that Mars is very dry. Life forms on Mars may have developed special ways of preserving their water content. There may be a kind of plant, an ice eater. We know that water-bearing rocks can be found on Mars, and creatures that actually digest the rock to extract water from it are possible.
It's particularly important for me, if I can throw a personal note in, because right at the time we were landing on Mars, right at the time we were trying to discover whether or not there is life on another planet, I am also going through a personal experience, which is considerably interesting. I'm having my first child. And the two together has caused me to be in a state of wonder at life and excitement about what's going on that I never would have thought was possible